Now I'm going to explain in this video the third colligative property. So children, so far we have seen the two colligative properties. First, the relatively varying vapor pressure. Second is the elevation in boiling point. Now third is, which is very important, children, and the third is called as depression in freezing point. Depression in freezing point. So when the solution undergoes freezing, or when a solution is allowed to undergo freeze, then the freezing point of the solution is lower than that of the pure solvent, and this is called as depression in freezing point. So when a solution is allowed to undergo freezing, then it freezes at a lower temperature than that of the pure solvent. And so this is the depression in freezing point, and it is because the solute, it prevents the solution to have a proper freezing point, and instead it undergoes at lower temperature. It freezes at lower temperature, and so this is called as depression in freezing point. Now you will see the graphical representation of this depression in freezing point, how you can represent graphically. So children, for this, similar to the elevation in boiling point, so on one axis we'll have the vapor pressure. On this there will be the vapor pressure, and here there will be the temperature. On this axis there will be temperature, and the solution freezes at lower temperature than that of the pure solvent, so you have to draw the curves for both the phases. So let the point be A. The solution is undergoing change in temperature. So this is the point B. At point B, there is the freezing of this solvent, or this is pure solvent. Then point B, it freezes, and so we draw here B to C. So this A to B, it indicates the liquid phase. B to C indicates the solid phase, and this B is the freezing point. B is the freezing point of pure solvent. So we'll draw perpendicular here. We draw perpendicular, and this is the freezing point. This point, let be the here 0 for our purpose of simplicity. So this point is the freezing point of solvent. Now we'll draw curve for the solution. Now the solution, take here, and so this is the solution, and so here this is the point. and let ABC, let this be D, and this is the point E. So this is the, in between C and D, it will freeze. There is the comparison, how it undergoes freezing at a lower temperature. And so D to E indicates the solution, and at this point it freezes. So this is the freezing point of solution containing the solute. Now this point, this freezing point of solvent, it will be called as TF naught. Naught indicates in the pure state, and this is the freezing point of solution. TF is the freezing point of solution, and the gap between the two. So this difference between TF naught and TF, it is called as delta TF. It is freezing point depression. So delta TF, it is freezing point depression. Then the depression in freezing point, because the solution containing solid will undergo freezing at a lower temperature. So it means this TF is lower than TF naught. Now, how we relate with the concentration or the molar concentration? So this delta TF, it is directly proportional to the molality, and when we remove this, so or it can written, it is written as Kf into M. So this Kf is called as molar depression constant. Molar depression constant. So molar pertains to, molar relates to the molality. When the solution having 1 molar strength and the depression in the freezing point which is being experienced is called as molar depression constant. So this is molar depression constant. Again, unit Kelvin, kg per mole. So molar depression constant, it means the solution having a strength of 1 molar. Now again coming to here. So this Kf again, so we put here the molality Wb by Mb into 1000 upon W in kg. So this is there. So this is called as depression in freezing point. So this is very, very important, that the solution always freezes at a lower temperature. You can experience, you take some water and similarly take some water containing some solute or something, milk or like that. So take the time taken. So water will freeze earlier because it is in pure condition, and the solution of the water will take more time. It indicates that it freezes at lower temperature because this is the nature.